In this video, we are going to talk about what is an engine, how it works, and how it will evolve in the next years. The term engine usually refers to petrol engines or diesel engines, but currently we can see vehicles with electric motors and hybrid vehicles. Let's start talking about the history of the engine. Today, many vehicles make use of the internal combustion engine, with slight variations depending on the vehicle types, having some added features or components. Developed in the 19th century, this type of engine still remains a popular choice, and it continues to benefit from the technological advances in engineering. Today's advanced engines may even feature computerized control and advanced systems to make them more efficient, durable, and powerful. Due to the evolution of technologies, engine can be more efficient. In order to be able to understand how an engine works, it is important to understand what the different engine parts are. Parts of the engine. Engines can come in several different varieties, with various parts depending on the type of vehicle it is. For example, a truck engine will be different as compared to the engine of a regular car due to the amount of power required. Spark plug. Gasoline engines make use of a spark to ignite the fuel and cause a controlled explosion in the engine. The spark plug in this engine supplies the spark that is required to ignite the air and fuel mixture. Valves. They allow for fuel and air to enter the combustion chamber and later let the exhaust out. They remain sealed during the combustion process and only open when required. Piston and piston rings. This is a cylindrical piece of metal that is located inside the cylinder of the engine. Piston rings are located between the piston and the cylinder in which the piston is located in. They provide a sealing edge between the exterior of the piston and the interior of the cylinder. They seal the space and prevent the fuel and air mixture on one side of the piston from leaking into the sump during the combustion or compressing process, and also prevent the oil in the sump from leaking into the combustion areas, as it will get burned and lost, deteriorating the movement of the piston. Connecting rod and crankshaft. The connecting rod connects the piston to the crankshaft. As the piston moves up and down due to the controlled explosions, it causes the connecting rod to move. This then causes the crankshaft to move as well as it is connecting to the connecting rod in a circular motion due to the configuration of the piston, connecting rod, and crankshaft. Sump. Surrounding the crankshaft, the sump contains some amount of oil. Fuel injectors are responsible for injecting the fuel into the combustion chamber. Diesel engines and petrol engines with direct injection. In petrol engines, it is injected into a combustion pre-chamber where the mixture is done before entering the combustion chamber. Cylinder block. This is when the combustion of fuel in enclosed sealed spaces called combustion chambers. The number of cylinders varies according to the engine design and can contain from 1 to 16 cylinders. Cylinder head. It is where the bulbs, injectors, and spark plugs are placed. It is headed to the top of the cylinder block.
Two things to note. There are different kinds of internal combustion engine. Diesel engines are one type and gas turbine engines are another. Each has its own advantage and disadvantage. There is also external combustion engine. The steam engine is old-fashioned trains and steamboats is the best example of an external combustion engine. The fuel in a steam engine burns outside the engine to create steam, and the steam creates motion inside the engine. Internal combustion is a lot more efficient than external combustion, plus an internal combustion engine is a lot smaller. Almost every car with a gasoline engine uses a four-stroke combustion cycle to convert gasoline into motion. The four-stroke approach is also known as the Otto cycle, in honor of Nicolas Otto, who invented it in 1867. They are intake stroke, compression stroke, combustion stroke, and exhaust stroke. The piston is connected to the crankshaft by a connecting rod. As the crankshaft revolves, it has the effect of resetting the cannon. Here what happens as the engine goes through its cycle. The piston starts at the top. The intake valve opens and the piston moves down to let the engine take a cylinder full of air and gasoline. This is the intake stroke. Only the tiniest drop of gasoline needs to be mixed into the air for this to work. Piston move a cap to compress this fuel-air mixture. Compression makes the explosion more powerful. This is the compression stroke. When the piston reaches the top of the stroke, the spark plug emits a spark to ignite the gasoline. The gasoline charge in the cylinder explodes, driving the pistons down. Once the piston hits the bottom of its stroke, the exhaust valve opens and the exhaust leaves the cylinder to go out the tailpipe. This is the exhaust stroke. Now the engine is ready for the next cycle, so it intake another charge of air and gas.
Now we're going to talk about the future of the engines. Some companies have been developing engines to add new ways to produce power, such as the gasoline compression ignition, which produces high levels of soot and nitrogen oxide emissions. In many ways, compression ignition is the right technology with the wrong fuel, because we need to change just the fuel while keeping on the compression ignition process. What GCI offers is the opportunity to eliminate emissions with a more volatile fuel such as gasoline. You can retain efficiency while reducing emissions significantly. You are talking about a 25 to 30% improvement in fuel consumption and carbon dioxide emissions. GCI enables ultra-low emissions but with efficiency of diesel engines. Another technology that is going to be implemented is a turbulent jet ignition that has been implemented in F1 type cars but not in production models. TGI mixes a small quantity of fuel with air in a very small cavity, which is combusted by a spark plug located within the cavity. The advantage is that combustion is now happening under the very lean conditions with a small quantity of fuel compared to the amount of air. The fuel consumption goes down significantly and efficiency increases. Is the opposed piston engines. This design allows you to double or quadruple the power density of an engine. In a conventional arrangement, cylinders are arranged in a row. A linear motion has to be converted into a rotational motion. The post-piston design uses two pistons per cylinder working in opposite reciprocating motion. This eliminates the need for a cylinder head and moving parts, so it reduces friction and heat loss. That energy is now converted to use, in a sense. Many companies are working to advance these concepts and make them more likely to go to production. So we expect to see this technology in production in the next 7 or 10 years. Another technology is the mobile carbon capture, which is focused on enabling technologies that would reduce carbon dioxide emissions either by improving the efficiency, which would result in carbon dioxide reduction, or by capturing carbon dioxide on board a vehicle. One of the biggest challenges of engines is the electric vehicle challenge, because total emissions standards have prompted the development of alternative fuel engines. About 20% of buses sold by MAN trucks and buses in 2016, for instance, had a gas engine. The company plans to start field tests of e-trucks and e-buses this year, and is entering partnerships for hybrid and electric vehicles. However, diesel and petrol-powered vehicles may still be able to compete if they can continue to reduce their emissions during use. Manufacturers also point to the amount of carbon currently emitted during the manufacture of electric batteries for EVs. In large part because of the electric consumed in production, and most of that electricity is still produced by thermal power plants.
Conclude, there are two factors that should be considered. Firstly, engines are crucial for a car. Each part of engine has a role that is important. Actually, there are different types of engine which have some advantage and disadvantage, depending on what automobile you need or want to use. However, nowadays, with new technology, people can develop new engines for new needs. We believe that as time goes by, new technologies will be developing and will have an epic impact on people. For example, autonomous vehicles and high investment that help electric cars and hybrid vehicles evolve for a better driving and less accidents. Furthermore, they will discover new ways of energy for a car, which will bring about new types of engine and designs. This can generate less emissions like sound emissions and carbon monoxide emissions. Although this leads to other challenges for industries and the government, they will have to work more efficiently and try not to contaminate.